All right, so yesterday we ended off talking about the ionic compounds, the kind of new rules that you hadn't learned in Science 9, how to name ionic compounds that have multivalent metals. So that involved putting in the Roman numerals, figuring out which Roman numeral to put in. Okay, we talked about naming ionic compounds that have polyatomic ions in them. And then we looked at how to build the formulas for an ionic compound if we were given the name. Right, so that's kind of the things we were working on here the last couple of days. Now we're going to look at molecular compounds, naming and writing the formulas. The reason we do this one last is it's really easy, and there's nothing different from what you learned last year about naming molecular compounds. These are the ones where you use the prefixes, and so it's pretty straightforward to do them. So we'll go over that, and then we'll get some time to practice kind of getting a mix of everything and identifying, is this molecular, is this ionic, does this one need a Roman numeral, does that one not, or whatever. Okay, so we'll kind of get into that today. So, the big thing about molecular compounds is that they are made up of two non-metals. Okay? Two or more, but we're going to just be dealing with two. Okay? So two non-metals, they react to form a new substance. What's different about molecular compounds from ionic compounds is what they do with the electrons. Ionic compounds trade them. Metals give them up, non-metals take them away. Okay? That's a weak bond, there's no need for them to stay together. But with molecular compounds, there's no balancing of charges. All nonmetals have negative charges. There's no way to balance the fact that everybody needs electrons to fill their outer shell. So the only way to do it is to share them. If you're sharing them, then you depend on that other molecule slash person, okay, or sorry, element slash person, okay, to give you that electron. You have to share it, which means you have to stay together. So these bonds are very, very strong. Okay? Molecular or covalent bonds are incredibly strong because nobody's happy if they break apart, because then their outer shells aren't full anymore. Their outer shells are only full while they're sharing the electrons. So the bonds are way, way stronger than ionic bonds are. Everybody with me there? Okay. Okay. So if we're naming these, so that's really all you need to know about molecular compounds. Okay, the bond is really, really strong. The electrons are shared. That's it. So you can highlight that part or something like that in your notes. Okay, in a molecular bond or covalent bond, electrons are shared, and this bond is very strong. Okay, that's the gist of molecular compounds. Because electrons are shared in molecular compounds, there's no fixed ratio for atoms to go together. Okay? We know that in an ionic compound, if calcium bonds with bromine, there's going to be one calcium and two bromines because that's the only way all the charges will balance. Okay? And so we don't have to use prefixes on that because there's only one way they can go together. There's lots of ways for molecular compounds to go together. Okay? Nitrogen and oxygen can pair up in all kinds of configurations, whether it be two nitrogens and one oxygen, or one nitrogen and two oxygens, or two nitrogens and three oxygens. There's really no rhyme or reason to how they can go together, so we have to have prefixes in the names, otherwise we'd run into that same problem we ran into with the multivalent metals. We have a whole bunch of compounds that are different that have the same name. Okay, so we have to use the prefixes in order to tell people in this molecular compound of nitrogen and oxygen, there are two nitrogens and one oxygen. Okay, or there are two nitrogens and three oxygens. So that's where we come in with the prefixes. Okay, so molecular compounds arise, like we said, when two or more nonmetals react to form a new substance. In these compounds, electrons are shared. Okay, the difference between naming these is that molecular compounds use prefixes to denote the number of atoms of each element that are involved. So, examples. If I have CS2, C is carbon, S is sulfur, carbon disulfide. Okay? This ide rule is still the same as it was before. The second atom, or the second element, gets its name changed to ide. Okay? Not the first one, only the second one. Okay? So the second element gets its ending changed to ide. All right? If we're looking at N2O, we would have dinitrogen. Actually, that's a mistake. That should say dinitrogen monoxide. Okay? just so we always end in I. All right, what are the prefixes? Because you don't have a list of them, so here they are. Probably want to write these down. 1 is mono, 2 is di, 3 is tri, 4 is tetra, and after that, it's all like geometry. 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. Okay, you won't need to know past 10. Okay, and you will have to memorize these. They're not on your periodic table. They're not going to be on a test. Okay, we expect you to know the prefixes up to 10. Okay, there is really only one little kind of tricky exception rule to naming molecular compounds. Okay? We use prefixes on everything except if the first element is a 1. Okay? So if I had the one that was up there before, N2O, okay, that would be dinitrogen monoxide. Okay, there's a prefix on both. But if I have this, this is carbon dioxide, not monocarbon dioxide. Okay, so for whatever reason, just because chemists have to be difficult and feel superior, they have to have some sort of strange rule, okay, that people have to remember. You never use mono on the first element. Use everything else. Okay, if it's a di or a tri or a tetra, whatever, you use that, but for whatever reason, you don't use mono on the first one. Okay, sorry, I don't make the rules, I just tell you what they are. Okay, questions on that? Okay, that's really all there is to naming molecular compounds. You just got to know the prefixes, okay, and put them on there, and remember not to use mono on the first one. Okay, well, let's have you guys try the first 4 here. Okay, see how we do with those, and we'll go through them in a minute. Okay, let's have a look at these. So on our first one, N stands for nitrogen. Okay, no prefix on that because there's only one of it. Okay, and I stands for iodine, which will change to iodide. And what prefix am I putting in front of it? Tri, right? So this is nitrogen triiodide. Okay, and if you got the 2 I's together, you should probably have a hyphen, I think. I don't know. I don't teach English. Something about that feels right, looks right. I don't know. Okay. All right. For number 2, we got 1 carbon, so we don't use a prefix because mono doesn't go on the first one, and 4 iodines this time. So what prefix is going in front of it? Tetra. Okay, questions on those 2? And then for our third one here, we've got 2 nitrogens, so now we do need a prefix on the first one. So we'll have dinitrogen. What are we going to have here? Trioxide, right? Okay, and for the last, or for number 4 here, we got Te, which is tellurium. There's no number here, so it's a 1. Okay, so we don't need a prefix. Tellurium, and then the prefix for 2 is di, astatide. Okay, questions on those 4? Don't be afraid to ask if there are. Okay, finish those ones off and we'll walk through them together real quick and then we'll try a mix of kind of everything. Okay, let's have a look at these ones here. So for number 5, what prefix am I putting in front of phosphorus? Di. Okay, so we got diphosphorus. And what am I going to end with? Not tetra, but trisulfide. Okay, and then for number 6, they're both 1s, right? We've got no little numbers here, so we've got no prefix on the first one. So we just have oxygen, and then we have monosulfide. Okay, and then for number 7, Si is Barrett, what's SI? Silicon. And what prefix am I putting on it? Tri. Okay, and then we're going to have tetra in front of phosphorus. Okay, and then for number 8, we've got no number on the sulfur, so we just have to write sulfur. And then we've got 2 on the chlorine, so that'll be dichloride. Questions so far?
Phosphorus.
Yep. Oh, sorry, phosphide. Good catch. Yep. Okay, and for number 9.
For number 8, isn't there a carbon in between the sulfur and the iodine?
It's not an iodine, it's Cl.
Oh,
It's chlorine.
that looked like.
Yeah, it's easy mistake. Easy mistake. Yeah. All right, number 9, we've got silicone again, and this time we got hydrogen, but hydrogen is listed second, which means it's behaving as a metal or non-metal? Non-metal. Okay, so this time it will be silicone tetrahydride. Okay, and then our last one here, we've got 4, so tetra boron tricarbide. How are we feeling about naming the molecular compounds? Okay, so it's even easier to write the formulas for molecular compounds because you've got the prefixes, they're telling you what numbers to write. Okay, so if we're going the other way, okay, and somebody gives us the name of a molecular compound, and let's say they give us I don't even know if this compound exists, I'm just making something up. Okay. Trinitrogen tetrafluoride. Okay, so the 2 things that are in here are nitrogen and fluorine. So I write the 2 symbols, right? And then I go with the prefixes. Tri is how many? 3. Tetra is how many? 4. Done. Okay, now, we said in ionic compounds that if you had a situation like this, let's just say that I ended up with this. If that was an ionic compound, what would I have to do with the numbers? Reduce them. In a molecular compound, you don't. Okay? If the molecular compound says di and hexa, that's the numbers. Okay? We don't reduce molecular compounds, just ionic ones. All right, everybody good with how to do the formulas for those? Like you just use the prefixes, they tell you what number to write, you write the numbers. Okay, pretty straightforward. All right, so here's a mix. Okay, some of these are ionic, some of them are molecular, some need Roman numerals. Yes, some need Roman numerals. Okay, and some have polyatomic ions in them. Okay, so you have to decide, is it ionic or molecular? Okay, so which naming rules do I use, and do I have to put a Roman numeral? Right, so now it's like the real challenge. Okay, you know they all don't follow the same rule. Okay, give you a few minutes to work on those. We'll do like the first 4, and then we'll give you a few more minutes to do another 4, and see how we do that. All right, so anytime we're naming compounds, the first thing we have to decide is the compound I'm looking at ionic or molecular, so I know which rules to apply. Okay? Number 1, we've got lithium and chlorine. Is that ionic or molecular? It's ionic, because lithium is a metal. Okay, metal first, non-metal second. So I need to apply the ionic compound naming rules. So that is, write the metal first, lithium, write the non-metal second, end it in "ide." Does this one need Roman numerals? Lithium only has 1 possible charge, so it doesn't need Roman numerals, so I'm done. That's it. Okay, it's just lithium chloride. Okay, for number 2, I've got chromium and fluorine. Ionic or molecular? It's ionic. Chromium is a metal. Okay, so I'm going to follow the ionic naming rules. Chromium, fluoride. Okay, does this one need Roman numerals? Okay, chromium can be a 2 or a 3, right? Okay, so in this case, which one is it? It's the 3, okay? And we do that by doing this. Fluorine is always a -1, and there are 3 fluorines, so that means I've got to get 3 positive charges from there. Chromium 3 fluoride. All right, number 3, phosphorus and bromine, ionic or molecular? This is molecular, yeah, they're both non-metals. So now I've got to go by the molecular naming rules. There's only 1 phosphorus, so it doesn't need a prefix. Okay, and it's with bromine, which I'll write bromide because it's second, and there are 3 of them, so what prefix needs to go here? Tri. Phosphorus tribromide. And then for number 4, I've got zinc and iodine. Ionic or molecular? It's ionic. Zinc is a metal, right? Is it going to need a Roman numeral? What do you think? Does zinc have more than 1 possible charge? Nope. So, simply zinc iodide. All right, give you a couple more minutes here. How many people are done up to number 8 already? Oh, okay, well, let's go up to number 8 then. Okay, number 5, silicone and oxygen, both non-metals, so this is molecular. So we apply the molecular naming rules. There's only 1 silicone, so I don't put a prefix on it, but there are 2 oxygens. All right, number 6, carbon and sulfur, both non-metals, so this one is molecular, and we are going to have carbon tetrasulfide. Okay, number 7, TCI7, so technetium is a metal. Iodine is a non-metal. What are we looking at here? Ionic or molecular? Ionic. Okay, so we follow the ionic naming rules. I believe on your periodic table technetium only has 1 charge, right? All right, and for number 8, so I've got sodium, oxygen, and hydrogen. Ionic or molecular? It's ionic, and the OH is a polyatomic ion. Does that really alter what I do? Nope, not really. Okay, I just follow the same rules. Sodium, and then I write the name of the polyatomic ion. In this case, hydroxide. Okay, keep going there, guys. Let's try and finish those off, and then we'll go through the rest here in a few minutes. Number 9, we've got calcium, and we've got a polyatomic ion sulfate, which incidentally did not need the brackets that are put around it, okay? Because there's no number outside of the brackets, right? This stuff would simply be calcium sulfate. Okay. Now for number 10, we've got potassium and another polyatomic ion. This stuff is permanganate. So potassium permanganate, okay? Which incidentally is little purple crystals that used to be used as a fungicide. With that, like back in like the Korean War and stuff like that, they used to kill athletes with fungus on the, like soldiers' feet and stuff. The only problem is it would stain your skin. Okay, it's little purple crystals, but the stain is brown. Okay, like if you have really fair skin, it is like a noticeably dark brown. And I only know that because I had a kid who never ever listened to me. And we were doing a lab where we used this stuff, and I explicitly said like 4 times, do not touch the crystals with your bare hands. And this kid was like pasty, like super pasty, and he picked up the crystals and he was playing with them, and he brought them over to me. He's like, there, these things are so cool. And I'm like, yeah, look at your fingers. Like from here to here, brown. Like where have your fingers been, brown. And it doesn't come off. You can't wash it off or anything. The tips of his fingers were stained brown for weeks. It was so fun. Okay, we'll talk to you guys on Monday. We'll be doing a little bit more of this stuff.